not working yesterday. All right. You're going to see a pattern today and the rest of this chapter. Your notes are going to look like this. All right. They're going to have a general formula. They're going to have a topic at the top. In this case, it's going to be alkenes. And then I'll have different ways. First, I'll have the properties of the alkenes. I'll talk about them. And then I'll have different ways to prepare alkenes and different ways to react alkenes and make other things. All right, so that's where and then we're going to talk about alkynes, and then we're going to talk about all the other alcohols, all the other different kinds of organic compounds. All right, so you'll get used to this. After a while, it becomes second half, and you just have to learn how to use those reactions, the general formulas, to write specific ones. You've already seen a little bit with alkanes, but in every case, I'm going to start with the properties. So let's start with the properties. By the way, you notice it's also called olefins. It's another name for alkenes. Maybe some of your grandparents. Maybe even some of your parents, I doubt it though, used to use a word called, my grandmother used to use a word called oleo for Crisco or oil. You ever hear the word oleo for like Crisco? Or shortening, vegetable shortening. All right, oleo, that's what it actually comes from. It comes from the fact that it's an alkene, has double bonds in it. And Crisco or vegetable shortening is basically artificially made oil turned into a solid. Because it's a little bit easier to transport a solid. It's a little bit easier. It lasts longer. So when we do that, unfortunately, you get trans fats as well, as you know from reading that thing. You add a little bit of saturation across those double bonds that would have been an oil. See, the more double bonds I have, the more of a chance it's going to be an oil. A saturated fat is going to most likely be a solid. Think about the saturated fats you're familiar with, like bacon fat or lard, any kind of animal fat. It's usually a solid. Whereas vegetables, ones with double bonds, alkenes, are usually a liquid, like vegetable oils, canola oil, peanut oil. All right. What do they make baby oil out of that, by the way? Babies?
Yeah.
Anyway, what they do is you partially saturate it, as you read about the thing, and in that article I gave you, and it makes them solid. And it will keep longer, and it's easier to transport than a liquid is. They first started doing this, I believe, in World War I, and that's where they came up with margarine instead of butter, because butter is a saturated fat. Anyway, that's another name for an alkene, an olefin. That's where the word oleo comes from. Let's talk about some of the properties of alkenes. You can write some of these down. They're similar to alkanes, but they're going to be more reactive, because and we'll talk about that in a minute. But they're similar in this way. They have nonpolar bonds, because the carbon-carbon bond, whether it's a double bond or a single bond, is still nonpolar. And the carbon-hydrogen bond is, of course, still nonpolar. And therefore, the alkenes are going to be insoluble in water. Of course, unlike alkanes, which are saturated, alkenes are unsaturated. That's the definition of unsaturation, is that they have double bonds in them. Therefore, they don't have all the hydrogens around. And of course, the biggest difference is I'm going to have a lot more reactions for alkenes than I had for alkanes. Alkanes were very inert. The three reactions I gave you they're not a whole lot, but one of them happened to be very important, burning them. But these guys are more reactive due to the double bond. The double bond is a region where atoms are sharing more than just one pair of electrons. So it's going to have a high negative charge there. It's not going to be a negative ion, but it's a region of high electron density, we call it. And that's going to attract positively charged groups that we call electrophiles. We actually go into that a lot more when we get to the mechanisms, which we'll do next chapter when we talk about mechanisms, how these reactions actually occur. There's actually one type of reaction, one type of mechanism called electrophilic addition. Okay, and that's where you add across the double bond, and a positively charged group will be attracted to this negative double bond. And that's why they're more reactive than alkanes. All right. Remember when I said a little bit about benzene? That when they first discovered benzene, they were kind of surprised because they knew it had unsaturation, yet it was way more stable than it should have been. All right. Most of the time when you have unsaturation, when you have double bonds, you get a real reactive compound, and benzene was pretty darn stable. All right, and benzene compounds, not just benzene, but all the aromatics. All right, there's the properties. Those are the things we're going to talk about in the test. I'll have you questions and multiple choice and matching and that kind of stuff. But let's get to the reactions, because that's what I really want to, that's what this chapter is mostly about. Preparation reactions. Now I'm going to break them down into two different types, preparation and reactions. All right, how do we make alkenes? Preparation. By the way, it's a great way to figure out, when you're going to get a worksheet, a handout, probably today. I don't know how far we're going to get. We have a double period, but I've got 2 demos to do for you, one of which is bonus. And by the way, I've already had a couple of questions on bonus. Asterisks are not zeros. If you have an asterisk, there's no reason to complain. It means you weren't here on the day I did something. But for bonus, a lot of you have asterisks because we did a bonus. We've done some bonus stuff. Very little, one paper, I think. And I'm going to do more maybe today if we do the music stuff, because I did it with the other class. But they just keep getting added into that column. And unless you have bonus points, you have an asterisk there. It doesn't mean you have a 0. It just means you don't have any points for it. And that goes for anything else. If you missed a lab, if you missed a worksheet, and I didn't ask you for it, if it doesn't say 0, you're okay. Okay, so don't worry about it. All right, how do we make alkenes? We're going to break them down into 2 different ways. You're either making the alkene or reacting an alkene. First way, cracking. You've seen this before. Do I need to talk about cracking? No, we saw cracking yesterday at the end of the period. All that happens is an alkane breaks up into a shorter alkane and a shorter alkene. Okay? So that's all you have to do is look at the cracking reaction. I already have one done. It is very non-specific, which means you don't know exactly what you're going to get when you break something like that by cracking it. All right. So I'm not going to, and this will happen multiple times. Guess what's going to happen under my preparation of alkanes? I'm going to have one of these preparation of alkanes is going to make an alcohol. I'm sorry, one of the reactions of alkanes is going to make an alcohol. That will be under preparation of alcohols and under reaction of alkenes. And that will happen. Things show up in more than one place. Dehydrohalogenation of alkyl halide. That's a great name. Sounds really impressive. If you look at the word, and I've said this 100 times, you've got to be able to read and break down words. And I always do this with you, whether it's amorphous or whatever I've done already in the past. Dehydrohalogenation of alkyl halides. To anyone else, is going to read it, it's just like, gobbledygook. Nobody knows what that means. But for you guys, you should be able to tell me in words what's going to happen in the dehydrohalogenation of an alkyl halide.
Water's going to go out of the...
Well, that's a good mistake. You think of hydro as water, but it really doesn't mean water in this case. What do you think it means? Just a hydrogen. Just a hydrogen. And what else is going to be what else does it say it's going to lose? A halogen. From what's an alkyl halide? What do you think an alkyl halide is? Just an alkane with a halogen on it. Chloroethane would be an alkyl halide. You see, if you just break it down, and I noticed that I expected to see that mistake with hydro. A lot of people think of hydro, you think of water, and usually we use that as a prefix for water too. But in this case, here's what actually happens. Watch, and it's also on your paper here. All right, I've got this. And by the way, your paper I have filled in, although I don't have filled in on here a lot of the dashes because I have using a word processor, and it's hard to fill this in. But basically, these dashes are there. All right. This guy is here, there's the hydrogens, all right, and in which case this would be that, all right, they're all filled in on your paper, right? Okay. So what's happening here? Well, let's take a look. This K and this X are getting together and ripping him off. The OH from here and the H from here are getting together and forming what? Water. So you're taking away a hydrogen and taking away a halogen from an alkyl halide, and you're using KOH and alcohol to do it. Now, I don't ask you to memorize all that. All right, you're not going to have to memorize that. You simply have to be able to apply it to a specific example. So let's do it a specific example. I don't think I have one here. On here? No. Okay, I'll just write one in. All right. So say I gave you this. Now, without me actually doing this problem, even after just one day of this, can you finish this up with exactly what I want you to write on the test? See if you can figure that out. Without me actually, I'm going to do it on the board anyway. But what do you think? Just using the general formula above and then naming everybody, could you do that on your own? Try that. Did you have that for the reaction? Okay, because you see what happened here. This chlorine and the H that's there, it's implied. I don't have it actually written. Now, they left and made a double bond. Now, where do they leave from? I don't care. If you put your double bond here, and you put it here, don't erase it. It doesn't matter. Either one's correct. All right? It can come off of either side there. This guy's name would be 2-chloropropane. And this guy would be 1-propene. Do I need to name the other guys? No, but I would hope you all can. Yeah.
Like I did, I had that, and then I only had OH on one side, right? But I didn't know if you actually could take just the hydrogen off that propane and then just make it double bond.
Well, yeah, that's what happens. That's exactly what happens. This X is going off with that K, so this X is going off with that K, and the other H is leaving and forming OH. H and OH are making your water. So you have to put water, not just OH over there. Okay? I was going to say something else, though, a second ago. I forget. Anyway, all right. It does have, I chose this one, I guess sometimes I make I should choose bigger compounds early on, but I don't want to waste too much time. Say I gave you a guy like this, and the double bond was here. Okay, sorry, not the double bond, but the chlorine was here, okay? I'll have people who will put the double bond pretty much anywhere in here. Where do you think the double bond is going to go if I have the chlorine on the end carbon? What's going to happen? It's going to form a double bond between here, right? When one of those two guys leave, right? All right, so if I've got a big, long compound, you don't just throw that double bond anywhere. You're going to put it where you took the hydrogen and the chlorine from, which would be like, this guy right here. Here I had a choice because either side's going to be the same, isn't it? All right, so I'm going to get, about half like that there, half like that. Probably going to look like that, And I want you to usually give me the most dominant product. All right. Now, due to resonance structures, you actually can get more than one product in a lot of cases. But I don't want you to give me the most dominant product, which would be, in the case of a guy like this, right there. It's not going to show up here or here or here or here. Okay? All right. Let me erase this. All right, so that's dehydrohalogenation. Let's look at dehydration. Now, this one is going to be removing what, you think? Notice the different word, not dehydro, but dehydration. This time it's going to remove water from an alcohol. Now, problem with that is you don't know how to name alcohols yet. Okay? So look what I have written down there. All right, I want you to wait for this one. Sometimes I'll do that. Since I haven't gotten to what alcohols are, you kind of know what they are anyway, right? I mean, they're going to have an OH in them. We've talked about them a little bit in doing the fermentation. But I'm going to wait until we get to the real stuff on alcohols. All right, reduction of alkynes is the next one. Now, have we seen that before? Basically, kind of like, we saw alkenes. I'm sorry. We didn't see that for alkenes. The reduction of alkenes to make alkanes. Did we yet? No, I don't think so. We add hydrogen across the double bond to make it alkane. Did I show that one in the first one? Yesterday? That was, no, those are just reactions of alkanes, right? All right, so we should probably do one. Do I have enough room there for one? See, Alkynes reaction number 1. Okay, well that's good. Okay, I do have alkynes reaction number 1 there. All right, so we'll wait for that one. Another case where we're going to wait to see that one under alkynes, and I'll do that one there. Okay. I'm going through these fairly quickly. All right, those are some of the ways to prepare an alkene. All right. I wanted to get to the reaction of an alkene because I have a little demo to do for you over there in the theme work. All right, so let's do that. Reactions of alkenes. First, we can have hydrogenation. And in hydrogenation, what happens is, what do you think happens? You add hydrogen, and you get an alkane. And that makes complete sense, doesn't it? If I just take, and this time I'm going to write a larger compound. And so you understand something here. This is kind of an interesting one I'm going to do on purpose. I'll bet there's a mistake you make in this one. Watch this. I can hydrogenate this alkene, and I'll turn him into an alkane. Okay? Now, that's not the hard part. What do you think happens when this hydrogen gets added to this guy? What do you think happens? Oh, and by the way, these guys have it's written on your thing, platinum or nickel as a catalyst. It's written on yours, right? Okay. It's hard for me to do that on these, to write stuff above or below. I mean, I can do it, but it's a pain. And so as long as it's on your papers, I don't really care. Write what happens over there. The hydrogen gets added across the double bond, and we get an alkane out of that. So draw the guy on the other side. There's always two mistakes that happen here, but I want you to draw them first so you make it now and you don't make it again. I know that won't happen. I know you're going to make it again, but just to show you. So draw the products and name everybody too. What do you think is going to happen here? And name them. I take my alkene, and I'm going to turn him into an alkane. So the double bond's going to be gone. You're just going to add hydrogen across him, and so he'll be gone. So make him, on the other side, an alkane, which means he doesn't have a double bond in him. Come on, you can do it. All you're going to do is draw that guy over there without the double bond. He's going to have a single bond because the hydrogen's going to add across him. But there's a mistake people make at this point. And I want to point it out to you because I see it all the time. I'm not exactly sure why I see it, but I do. So sometimes, like, even I know the mistakes you make, but sometimes I'm still amazed by why they're made. I don't really understand it. And make sure you name the guy. Name that guy and name the guy on this side too. Name both. Because that's the second mistake. There are two mistakes made here. All right, let's go with the first one. Here's the first mistake. That's your first mistake. They got rid of the double bond. They added hydrogen across it. But then they forget about the methyl groups that were over there. They just don't draw them. Did anybody do that? Anybody not draw the methyl groups over there? You will on the worksheets. For some reason, people just leave them out. They didn't disappear. They're still there. It's the exact same compound. I just added hydrogen across the double bond. I put one here and I put one there. You know? That's what I did. So that's one mistake. But here's a bigger one. More common to see. All right, watch. This guy's name is, I have to start from this side, 1, 2, 3, 4, 4. Dimethyl 1, 2, 3, 4, 5 pentene. 4,4-dimethyl 1 pentane, right? So that if I take away the double bond, that means this guy's 4,4-dimethyl pentane, right? No. Now I gotta name it from that side. I gotta start numbering them from that side. This guy is 2,2-dimethyl pentane. All right, so these are the little tricks, and for whatever reason, I see every year, and I try to point them out to you. And, of course, you don't get good at this until you do a lot of worksheets. I'm pretty sure if we have time, we'll get to the first worksheet by the end of the second period today, let you start working on it. But I don't know exactly how much time we're going to get to. We have the announcements, too. All right, everybody go with that? So that's hydrogenation. Now the next one, we're going to do a very similar thing. By the way, the reason alkenes are more reactive because of this double bond. What we're going to find is we have a lot of reactions of alkenes, not just on this one sheet. I got another sheet to give you this next half of the period. The next thing I'm going to add across that double bond, this time, instead of hydrogen, is going to be halogens. Halogenation, right? So if I add a halogen across, here's my general formula. Okay, it looks kind of like this. You have them all filled in, I think, right? All right. So that's what your general formula looks like. You're going to take your alkene. You see why that's an alkene? R means some amount of carbons going that way, and some amount of carbons going this way, right? And I'm going to add these two guys across. And this is the one I want to do for you as a demo. But I'm going to do the equation first. It's not going to be the same one I do in the fuelment. The one I'm going to do in the fuelment is a little bit different. I want to use a slightly larger compound to show you this one. So try this guy. Try that guy. And then I'm going to stop the video after we finish this guy up and do the demo, because you can't see the demo on the video to show you that. Okay, so check that guy out. Finish him up. Draw the new compound on the other side and name everybody. Okay, now I got 4 carbons, no doubt about that. I'm not losing that. The F's go where? Anywhere? Like one here and one there? Where do you think they're going to go? Where the double bond was. They're going to go one on this side of the double bond and one on that side, right? Okay? So I would call this guy on the left 1-butene. And this guy on the right 1,2-dimethyl. I'm sorry, difluoro. Butane. 1,2-difluorobutane. I said it again. Difluorobutane. Right? Okay? So I wouldn't just put the F's anywhere. I would want to put them next to wherever the double bond was. Okay? On either side. All right, good enough. Now, I want to stop this.